champs of Examsnet. Welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So today we are going to discuss chemistry questions from NEET ODISHA 2019 paper, and we have 45 questions here. So let's start the session. The first question is from the chapter Aldehydes, Ketones and Carboxylic Acids. And the question is the reaction that does not give benzoic acid as the major product is. Okay, so we can see that in all the given options, alcohol is the reactant. Okay, that means we have to convert alcohol into the acid. Now, we know that alcohols need to get oxidized in order to get converted into an aldehyde or ketone, right? Aldehydes or ketones based on the position of hydroxyl group. Okay, then these aldehydes and ketones further get oxidized to get converted into carboxylic acids. Okay, carboxylic acids. But if we have to convert alcohols directly into carboxylic acids, then very strong oxidizing agents are used. Okay, very strong oxidizing agents can convert all alcohols directly into the carboxylic acids. Okay, oxidizing agents. And what are the examples of such strong oxidizing agents? Some of the well-known examples are potassium dichromate K2Cr2O7 and potassium permanganate, that is KMnO4. Okay, now let's come to the options here. In the first one we can see we have an alcohol, and what reagent is being used? Potassium dichromate is being used. And just now we saw that potassium dichromate is a very strong oxidizing agent which is capable of converting an alcohol into carboxylic acid directly. So yes, benzoic acid will be formed in this case. Okay, benzoic acid. Now in the second one we have a ketone. Okay, and NaOCl is used. So here also carboxylic acid will be formed, in this case benzoic acid particularly, because these aldehydes or ketones can easily be converted into carboxylic acid. Okay, so we don't have to worry about the reagent or the type of reagent here. Now let's come to the third one. Here we can see we have an alcohol and PCC is used, and we know that this is a mild oxidizing agent. Okay, this is a mild oxidizing agent. That means this cannot convert an alcohol directly into carboxylic acid. Instead, it will be converted into an aldehyde or ketone, and in this case particularly an aldehyde will be formed, that is benzaldehyde. Okay, so benzoic acid will not be formed in this case, so this will be the correct option. In the last one also we can see we have an alcohol as the reactant, but very strong oxidizing agent, that is potassium permanganate is being used. So this will also lead to the formation of benzoic acid. Okay, let's see the structure of benzoic acid. This is the benzene ring. Here we have carbon, oxygen, oxygen and hydrogen. Okay, so the benzoic acid will be formed in case of first, second and fourth options, but in the third one benzaldehyde will be formed. Question number 47 is from the chapter amines, and the question is the amine that reacts with Hinsberg's reagent to give an alkali insoluble product is. Okay, that means the product has to be insoluble in a base. Now first of all, what is a Hinsberg reagent? Hinsberg's reagent is benzene sulfonyl chloride. Okay, it is benzene sulfonyl chloride. Let's have a look at the structure. We have a benzene ring here. Then here we have a sulfur, double bond oxygen, and one single bond chlorine. Okay, so this is Hinsberg's reagent. Now it is used for the detection of primary, secondary and tertiary amines. Okay, for detection of 1 degree, 2 degree and 3 degree amines. That means it will be able to differentiate among these three types of amines. Okay, now let's have a look at the reaction of this Hinsberg reagent with primary, secondary and tertiary amines. So firstly we'll see the reaction of primary amines with Hinsberg's reagent. So suppose we have a primary amine, say C2H5NH2. Okay, you can take any alkyl group, it can be methyl group or propyl group or any one group. So this amine will react with our Hinsberg's reagent. Okay, that means benzene ring here. Then here we have sulfur, two oxygens are there, and one chlorine is there. Okay, so what happens during the reaction? One hydrogen from the amine will be removed. Okay, one hydrogen will be removed, and this chlorine from the Hinsberg reagent will also be removed. So hydrogen chloride will be removed. So what will be formed? Let's have a look at the product. C2H5, then nitrogen, one hydrogen, because NH2, from NH2 one hydrogen has been removed, so only one hydrogen is left here. And then this side we have sulfur, two oxygens are there, and benzene ring is there. Okay, so we can see that we have one hydrogen in this product. Okay, so this will make this product soluble in alkali. Okay, so this will be soluble in alkali. That means in case of primary amine, the product will be soluble in alkali. In the second one, that means secondary amines. Let's have a look at the reaction. So in secondary amines, we'll have two alkyl groups. Okay, so this is nitrogen. Suppose these are alkyl groups, and we have only one hydrogen with nitrogen, right? And this side we have Hinsberg reagent. So sulfur oxygen double bond, then two oxygens, one chlorine, and then we have a benzyl group. Okay, so here again what will happen? The hydrogen will be removed, okay, from the amine, and chlorine from the Hinsberg reagent will be removed. So what will be left here? This time no hydrogen will be left in amines, because only one hydrogen was there, and that is also removed. So let's see what will be the product. Nitrogen, then here we have two alkyl groups, then sulfur, oxygen, and then benzene. Okay, so we can see there is no hydrogen with nitrogen, therefore this will be insoluble in alkali. Okay, that means any secondary amine that will react with Hinsberg reagent will lead to the product that will be insoluble in alkali. Okay, now what will happen in case of tertiary amines? Tertiary amines, we have three alkyl groups. Okay, and here we have Hinsberg's reagent. So I'm not writing the whole structure of Hinsberg reagent because no reaction will take place, since this nitrogen of amine has no hydrogen with it. So from where will the hydrogen be removed? Okay, so no hydrogen is there for removal. That means no reaction will take place in case of tertiary amines. So got it? Here it is asked in the question that the product has to be alkali insoluble, and we have seen that only in case of secondary amines the product will be insoluble. So let's have a look at the given options. In the first one we can see that we have a secondary amine, okay, because we have two alkyl groups, okay, and one hydrogen. So this is secondary amine, so this will be insoluble. Okay, now in the second one we have a tertiary amines. We have three alkyl groups, one R1, R2, and R3. Okay, so no hydrogen is there with nitrogen, that means no reaction will take place. In the third one we have primary amine, okay, NH2 is there, that means two hydrogen, so one will be removed and one will be left, and that will make it soluble in alkali. In the last one also we have NH2, that means a primary amine, therefore these two will be soluble in alkali because of presence of one hydrogen in the product. Okay, so the correct option will be option number A. This is a secondary amine, therefore the product will be insoluble in alkali. Question number 48 is from the chapter Biomolecules, and the question is, which structure or structures of proteins remain intact during denaturation process? Options are both secondary and tertiary structures, then primary structure only, then secondary structure only, and the last one is tertiary structure only. Okay, so what do we mean by denaturation process? It is the process of modification of molecular structure of proteins. Okay, modifications of molecular structure of proteins. And here we have to remember that only secondary and tertiary structures are modified. Okay, so only 2 degree, that is secondary, and 3 degree, that is tertiary structures are destroyed or modified during the denaturation. That means primary structure remains intact or unaffected. 1 degree remains intact. So here we have to answer which structure remains intact during denaturation. So the correct option will be option number B, that is primary structure only. Question number 49 is from the chapter Polymers, and the question is the polymer that is used as a substitute for wool in making commercial fibers is. Options are melamine, nylon 66, polyacrylonitrile, and the last one is bunion. Okay, so this is a direct question. You can just remember that it is polyacrylonitrile that is used as substitute for wool in making commercial fibers such as orlon, Orlon or acrylan. Okay, so option number C will be the correct answer. And what is the structure of polyacrylonitrile? It looks something like this. This is CH2CH polymer of this, and then C triple bond nitrogen. Okay, so this is polyacrylonitrile. Question number 50 is from the chapter Chemistry in Everyday Life, and the question is the artificial sweetener stable at cooking temperature and does not provide calories is. Options are saccharin, aspartame, sucralose and allitame, and the correct option will be option number C, that is sucralose. So what is sucralose? It is a trichloro derivative of sucrose. Okay, trichloro derivative of sucrose. It is stable at cooking temperature. Stable at cooking temperature and does not provide any calorie. And its sweetness is about 600 times sweeter than the cane sugar. Okay. And which one is unstable at cooking temperature? The second one, that is aspartame. Okay. This is unstable at cooking temperature. Then where is it used? It is limited to cold foods only. Cold food or soft drinks only. What about its sweetness? It is about 100 times sweeter than the cane sugar. Okay. And the last one, that is allitame, is the sweetest of all because it is about 2000 times sweeter than the cane sugar. Therefore, it is very difficult to control the sweetness of food in which allitame is used. Okay. And what about saccharin? It is about 550 times sweeter than the cane sugar. So, according to the question, our correct answer is option number C, sucralose. Question number 51 is from the chapter Environmental Chemistry, and the question is the liquefied gas that is used in dry cleaning along with suitable detergent is. Options are water gas, petroleum gas, nitrogen dioxide and carbon dioxide, and the correct option is option number D, that is carbon dioxide. Okay, so liquid carbon dioxide is used in dry cleaning along with suitable detergent. What was used earlier? Earlier tetrachloroethene was used. Okay, tetrachloroethene, that means carbon carbon double bond and 2 chlorine to this and 2 chlorine to this. So tetrachloroethene was used earlier as a solvent for dry cleaning. Let's write it down here. Was used earlier, but nowadays it has been replaced by the liquefied carbon dioxide gas. And what is the reason behind that? The reason is that tetrachloroethene often contaminates the groundwater. Contaminates the ground water, and also it is a suspected carcinogen. Therefore, liquefied carbon dioxide is relatively safer. Okay, that's why this is used. And what is water gas? This is carbon monoxide plus hydrogen gas. and it is used as a producer gas for the production of fuel gas. Okay, producer gas, and this is also the common name of water gas. Then what is petroleum gas? We know that one of the very common petroleum gas is LPG, that is liquefied petroleum gas, and it is used in cooking. Also, it is used in some potable heaters. And the last one is nitrogen dioxide. It is generally used as oxidizing agent. So I hope you understood this question. Question number 52 is from the chapter Organic Chemistry, and the question is the hydrolysis reaction that takes place at the slowest rate among the following is. Okay, so here we can see in the given options we either have alkyl halide or aryl halide as the reactant, and these are reacting with aqueous sodium hydroxide. Okay, and we have to tell which one will react at the slowest rate. So first of all, what kind of reaction is taking place here? Hydrolysis reaction. That is an example of nucleophilic substitution reaction, that is SN1 reaction. Okay, so here you can simply remember a fact that aryl halides don't show nucleophilic substitution reaction easily. Okay, aryl halide don't show nucleophilic substitution reaction easily at room temperature. So out of the given options, it is only first option where an aryl halide is used. Okay, so this will not take place easily. That means option A will be the correct answer. Whereas in all the other options, you can see alkyl halides are used. Okay, here also in the last one, alkyl halide is used. Benzene is present as the benzyl group. Okay, now you can use another method because SN1 reaction is affected by the stability of carbocation. Okay, stability of carbocation. So you can check the stability of carbocation in each case. So first of all, what will happen? The chlorine group, that means the halogen group, will be removed. Okay, so the carbocation will be formed. So let's check what will be the carbocation in first case. This is the benzene ring. Here we have methyl group, and here we'll have a plus charge, okay, when chlorine will be removed. So this is the carbocation. In the second one, the carbocation will be CH3 CH2 plus. Okay, in the third one we have CH2 double bond CH, then single bond CH2, and then plus charge here. Okay, and what will be the carbocation in the last one? We have a benzene ring here, and then here CH2 plus. Okay, now you can see that in the last one we have alternate single and double bond. Okay, in benzene ring we have alternate single and double bond. So this will show resonance effect. Resonance effect. Similarly, in the third option also we have alternate single double bond. So this will also show resonance effect. And we know that resonance effect lead to the stability of the compound. Okay, so these two will lead to the formation of stable carbocations. Okay, now in the second one also, here also it will be stable because of plus hyperconjugation effect and plus I effect. Okay, but in the first one we have an sp2 carbon that will make it unstable. Okay, so option A will be the correct choice here. Question number 53 is from the chapter Alcohols, Phenols and Ethers, and the question is when vapors of a secondary alcohol is passed over heated copper at 573 Kelvin, then the product formed is. Options are a carboxylic acid, an aldehyde, a ketone or an alkene. So the correct option will be option number C, that is a ketone. Okay, so what kind of reaction will take place? Dehydrogenation reaction will take place. Okay, dehydrogenation reaction, that means removal of a hydrogen molecule. H2 will be removed from here. Okay, let's have a look at the reaction. we have a secondary alcohol. That means two alkyl groups will be there, right? And one hydroxyl group and one hydrogen. Okay, so dehydrogenation, that means two hydrogens have to be removed. So one hydrogen from here will be removed, and one hydrogen that is with oxygen, that will also be removed. So what will be formed? Alkyl group, then carbon oxygen double bond, and then another alkyl group. That means a ketone is formed. Okay, now what would have formed in case of a primary alcohol? An aldehyde. Okay, let's see the reaction. Primary alcohol, the reaction is one alkyl group will be there. So it's RCH2OH. Now it is passed over copper. 573 Kelvin temperature is used. So an aldehyde will be formed. Okay. Now what would happen in case of a tertiary alcohol? That means 3-degree alcohol. Let's see. In this case, dehydrogenation will not take place. Okay. In first and second case, both dehydrogenation reaction takes place. But in the third case, that means in case of tertiary alcohol, dehydration reaction takes place. Okay, dehydration. That means removal of a water molecule. So let's have a look at the reaction. Carbon, then three alkyl groups will be there. Let's take three methyl groups. And here we have hydroxyl group. Okay. Now it is passed over copper. Temperature is 573 Kelvin. So we have CH3 carbon. Here CH3. Here double bond CH2. Okay, that means OH is removed and one hydrogen has been removed. Okay, water molecule has been removed. Okay, so what is formed in this case? An alkene is formed. So alkene will be formed in case of 3-degree alcohol, whereas an aldehyde will be formed in case of 1-degree alcohol. Okay, but in the question secondary alcohol is mentioned, so option C, that is a ketone, will be formed. Okay. Question number 54 is again from the chapter Alcohols, Phenols and Ethers, and the question is the major products C and D formed in the following reactions respectively are. Okay, so we can see we have an ether as the reactant, we have oxygen here and two alkyl groups on both the sides. So this is an ether. Now this ether is being heated in the presence of excess of hydrogen iodide to give two products C and D. Okay, so let's see what is the general reaction of ether with excess of hydrogen iodide. So whenever ether reacts with hydrogen iodide, so in this case we are taking limited amount of hydrogen iodide. Okay, limited amount of hydrogen iodide. So an alcohol is formed, alcohol, and an alkyl iodide is formed. Okay, so two types of products are formed. But in case of excess hydrogen iodide, this alcohol further reacts with hydrogen iodide to give an alkyl halide. Okay, alkyl iodide particularly. So what will happen? Two alkyl iodides will be formed only. Okay, so since we have excess hydrogen iodide, so there should be two alkyl iodide in the product. So in the first option only we have two alkyl iodides. Okay, so this will be the correct option. In the second one we have one alcohol and one alkyl iodide. In the third one again we have one alcohol and one alkyl iodide. So these will be possible in case of limited amount of hydrogen iodide. Okay, in the last one we have two alcohols only, so this is not at all possible. Okay, so the correct choice is only option number A. Question number 55 is from the chapter Classification of Elements and Periodicity in Properties, and the question is match the oxide given in column A with its property given in column B. Okay, so we have two types of oxides here. Some are metal oxides, some are non-metal oxides. So we can remember a general rule here that metals give basic oxides. Okay, that means metal oxides are basic in nature, whereas non-metal oxides are acidic in nature. And there are some exceptions also. For example, aluminium. Aluminium, this is exceptional because it gives an amphoteric oxide. Okay, amphoteric oxide. That means it will react with acid as well as base. So here the first one is sodium oxide. So we know that sodium is a metal, that means this will make a basic oxide. Okay, so the correct match for 1 will be number B. Now the next one is aluminium oxide. So we have seen that aluminium is an exceptional element that gives amphoteric oxide. So the correct match for 2 will be D, that is amphoteric. Third one is nitrous oxide. So again this is special because this is neither acidic nor basic. So this is a neutral oxide. Okay, so the correct match for 3 will be number A, neutral oxide. And here you can remember one thing, that nitrous oxide is known as laughing gas. Okay, this is an important fact. So you can just remember this. Now the last one is oxide of chlorine. Okay, so chlorine is a non-metal and we know that non-metal give acidic oxide. So the correct match for 4 will be number C, acidic. So which one will be the correct option? The last one. Okay, option D will be the correct option. Now question number 56 includes concepts from different chapters, and here we have to match the names of catalyst with the correct process. Okay, so the first catalyst mentioned is vanadium pentaoxide, and it is used in the contact process that is carried out in the manufacture of sulfuric acid. Okay, so the correct match for 1 will be number C. Now we know that contact process has different steps. So one of these steps is the oxidation of sulfur dioxide to form sulfur trioxide. Okay, and in this step this vanadium pentaoxide is used. Okay, the balanced equation will be this. Okay, now the next one is titanium tetrachloride and trimethyl aluminium. Okay, so let's write it down. What is it known as? Titanium tetrachloride plus trimethyl aluminium. This is known as Ziegler-Natta catalyst. Okay, Ziegler-Natta catalyst, and it is used in the polymerization of ethylene to give high density polythene. Okay, high density polythene. So this is used as a catalyst to make high density polythene by polymerization of ethylene. So the correct match for number 2 will be D. Okay. Now, the third one is palladium dichloride, and it is used in the oxidation of ethine to ethanol. That means number A will be the correct match for this, and the process is Backus process. Okay, and the last one is nickel complexes. So the only option left is the second one, polymerization of alkynes. So in this, nickel complexes are used. So the match for 4 will be B. Okay, so the correct option out of the given 4 will be the first one. Okay, so option A will be the correct answer. Question number 57 is from the chapter Organic Chemistry, and the question is the most stable carbocation among the following is. Okay, so here we don't have any double bond, so there is no use of resonance effect here. So we can use hyperconjugation effect to determine the stability of the given carbocations. Okay, hyperconjugation effect. Now from here we know that the stability of carbocation will depend on the number of alpha hydrogens. Okay, that means more the number of alpha hydrogens, more will be the stability of that particular carbocation. So let's count the number of alpha hydrogens in each of the given options. In the first one, this is the carbocation, this is the carbon having positive charge. So on the left side of it, we have no hydrogen attached to this carbon. Okay, so we have no alpha hydrogen on the left side. Now on the right side, we have 3 hydrogens attached to the alpha carbon. So total number of alpha hydrogens will be 3. Okay, so 3 alpha hydrogens. In the next one, that means the second number, this is the cation, and on the left side we have 2 alpha hydrogens. On the right side again we have 2 alpha hydrogens. So we have total 4 alpha hydrogens. That means this will be more stable than the previous one. Okay, then in the third one we have, this is CH2. Okay, now on the left side of this cationic carbon, we have 3 alpha hydrogens. On the right side, we have 2 alpha hydrogens. So the total number of alpha hydrogens will be 3 plus 2, that is 5 alpha hydrogens. This will be more stable than the previous two. And in the last one, this is the cationic carbon. On the left side we have 2 alpha hydrogens. So total number of alpha hydrogen is 2 only. Okay. So the maximum number of alpha hydrogens is present in the third one. So the third option will be the correct answer. Question number 58 is from the chapter Hydrocarbons, and the question is the alkane that gives only one monochloro product on chlorination with chlorine in the presence of diffused sunlight is. Okay, so what is chlorination? It is basically an example of substitution reaction. Okay, substitution reaction in which hydrogen gets replaced by the chlorine, gets replaced by chlorine. And since the reaction is taking place in the presence of diffused sunlight, therefore free radical mechanism will be followed. Free radical mechanism. Now here we have four options: 2,2-dimethylbutane, neopentane, N-pentane and isopentane, and we have to find out that alkane that gives only one monochloro product. Okay, that means only one type of product will be formed. So here for the formation of monochloro product, only one type of alpha hydrogens should be present. Okay, only one type of alpha hydrogens should be present. Now, let's see one by one. In the first option, we have 2,2-dimethylbutane. So, butane means 4 carbon in a chain. So, 4 carbons. And 2,2-dimethyl, that means at second position, we'll have 2 methyl groups. Okay. So, CH3, CH3. Here we'll have CH3. Here we'll have CH2. And again, this side, we have CH3 again. Okay. So chlorination will take place. So how many types of products will be formed? See, here we have different types of alpha hydrogens. For example, this is one type A, okay, and similar type will be these two also, okay. So these three are of same types, okay. In this one we have another type of alpha hydrogen, and in the last one again we have another type of alpha hydrogens. So different types of products are being formed. Basically, three types of products will be formed, okay. So this will not be the correct answer, okay, because only one type of product should be formed according to the question. Now if we consider the second option, we have neopentane here. So let's draw the structure of neopentane. Neopentane, that means one carbon this side, then CH3, CH3, CH3 and CH3. Okay, so here you can see that all are same types of alpha hydrogens. Okay, that means no matter which hydrogen is replaced, it will lead to the formation of only one type of product. Okay, so the correct option will be number B, that is neopentane. You can try for N-pentane and isopentane also. These also have different types of alpha hydrogens. So more than one types of products will be formed in these cases also. Only in case of neopentane, only one type of product is possible. Question number 59 is from the chapter Hydrocarbons. Here a reaction is given and we have to find out the number of sigma bonds present in the product A. That means a certain product A is being formed here. So we can see on the reactant side we have an alkene. Red hot iron tube is being used and the temperature is 873 Kelvin. So this is the example of cyclic polymerization reaction. Okay, cyclic polymerization reaction. That means a cyclic product will be formed. Now here we have 3 carbons in the reactant and 3 molecules of this reactant will be reacting. Okay, 3 molecules of the reactant will take part in the reaction. One molecule has 3 carbons, so 3 molecules will have 3 into 3 carbons, that means 9 carbons. Okay, Out of these 9 carbons, 6 carbons will be utilized in making the cyclic ring, that means the benzene ring. So this is the benzene ring with alternate double bonds, and the remaining 3 carbons will be present as methyl groups. So one methyl group here, one methyl group here, one methyl group here, and at the remaining positions hydrogen will be there. So this is the product A. Now let's count the number of sigma bonds. So how many sigma bonds in each methyl group? 3. Okay, so 3 sigma bonds in this methyl group, 3 here and 3 here. Okay, so 9 sigma bonds plus the sigma bond attaching the ring with other groups are 1, 2, 3, 4, 5, 6. 6, and how many sigma bonds in the benzene ring? 1, 2, 3, 4, 5, 6. Okay, so 6 in the benzene ring, 6 attaching the benzene ring with another group, and 9 in the methyl groups. So total will be 21 sigma bonds. Okay, that means option number A will be the correct answer. Question number 60 is from the chapter Coordination Compound, and the question is aluminium chloride in acidified aqueous solution forms a complex A in which hybridization state of aluminium is B. What are A and B respectively? Okay, so we have aluminium chloride, that means AlCl3. Actually, 2 molecules of aluminium chloride will take part in the reaction. So Al2Cl6 will be there. Okay, and there is aqueous solution, that means these will react with water molecules. Also the solution is acidified, so H plus or H3O plus ions will be there. Okay, now we have to tell what complex, that is A, will be formed here. Okay, so in place of these 6 chlorine, 6 water molecules will be added. So Al, then 6 water molecules, and then 3 plus charge will be there. Okay, so this is the complex A. Okay, now we have to tell the hybridization of aluminium in this complex. So for that, let's write down the electronic configuration of aluminium. It is 3s2 3p1. Now let's fill these electrons in the orbitals. So we have 3s orbital, then 3p orbital, and then aluminium also has vacant d orbitals. Okay, so this is 3d orbital. Now 2 electrons in 3s orbital, so 2 electrons filled. 1 electron in 3p orbital, so 1 electron filled. Now during this reaction, first the aluminium will get converted into aluminium 3 plus ion. Okay, so its electronic configuration will be 3s0 3p0, that means these 3 electrons will be removed. Okay, so all these orbitals 3s 3p will remain vacant. Okay, and 3d orbital was already vacant, right? So now we have to fill these orbitals. So how will these orbitals be filled? These will be filled by the electrons donated by the water molecules. Okay, so how many water molecules are there in this complex? 6 water molecules. So let's write it down here. 1, 2, 3, 4, 5, 6. So each water molecule will donate one pair of electron. Okay, so this is one water molecule, this will donate here, so one pair filled here. Okay, this will fill here, so 3 water molecules in these 3 orbitals, so 3p orbital filled. Now 2 water molecules left, so one in this one and one in the next one. Okay, so as we can see that one s orbital is filled, then all the 3 p orbitals are filled, so sp3. And how many d orbitals are filled? 2 out of 5, 2 are filled, so it's sp3d2. That means this is the hybridization of aluminium in this complex, and the shape will be octahedral. Okay, the shape for sp3d2 is octahedral. So the correct answer will be option number A. This is the complex and sp3d2 is the hybridization. Question number 61 is from the P block elements, and the question is which of the following compounds is used in cosmetic surgery? Options are silica, silicates, silicones and zeolites, and the correct option will be option number C, that is silicones. So what are silicones? These are group of organosilicon polymers. Okay, So let's write it down here. Organo silicon polymers. What is repeating unit here? R2SiO is the repeating unit. That means silicon is there, oxygen is there, two alkyl groups are there, R1 and R2, and then this will be repeating. Okay. Now, what are the characteristics of silicones? There are several characteristics. One of them is non-polar nature. Okay. These are non-polar in nature and therefore these work as water repellent. Okay. Repellent of water, or you can say these are hydrophobic in nature. Then these have high thermal stability, high dielectric strength, and resistance to oxidation and chemicals. Resistance to oxidation and chemicals. And these have wide applications. For example, let's write it down here. Applications. One of the application is already mentioned in the question. These are used in cosmetic surgery because of being biocompatible. Okay. So these are used in cosmetic and surgical plants. Why? Because these are biocompatible. Other applications are, these are used as sealant, greases, electric insulators, etc. Okay. So this was all about the silicones. Question number 62 is from the chapter General Principles and Processes of Isolation of Elements. And here we have to identify the incorrect statement. Okay. So the first statement says the scientific and technological process used for isolation of metals from its ore is known as metallurgy. So this is simple definition of metallurgy and this is a correct definition. So this is a correct statement. Okay. Second statement says minerals are naturally occurring chemical substances in the earth's crust. So this is also right, we know. Okay, these occur naturally in the crust of the earth. Now, third statement says ores are minerals that may contain a metal. Now this is again a correct statement because we extract metals from ores only. Okay. And the last statement says gangue is an ore contaminated with undesired materials. Now this is an incorrect statement because gangues are undesired materials, that is true, but these are not ore. Okay, these are not ore. Therefore, this is an incorrect statement. These are just undesired material present in the ore. Okay, these are undesired material present in the ore. These are not themselves ore. Okay. So option D will be the incorrect statement. Question number 63 is from the P block elements and the question is a compound X upon reaction with water produces a colorless gas Y with rotten fish smell. Gas Y is absorbed in a solution of copper sulfate to give copper phosphide as one of the products. Predict the compound X. Okay, so we have a compound X that reacts with water to give a colorless gas Y that has smell like a rotten fish. Okay, so we know that phosphine gas smells like rotten fish. Okay, so this will be pH 3, that means phosphine. So let's write the complete reaction. What should be this compound X? It is calcium phosphide, that is Ca3P2. Okay, and when it reacts with water it leads to the formation of calcium hydroxide and a colorless gas, that is phosphine, which smells like rotten fish. Okay, so this is gas Y. So now we have already got our compound X. This is calcium phosphide. So option A will be the correct answer. Now we can complete this reaction. It is given as gas Y, that is phosphine, is absorbed in a solution of copper sulfate to give copper phosphide. So let's write down the reaction for that also. Copper sulfate plus phosphine is absorbed in it. So it will give Cu3P2, that is copper phosphide plus sulfuric acid. So I hope you understood this. Question number 64 is again from the P block elements, and the question is, which of the following oxoacids of phosphorus has strongest reducing property? Okay, so we know that the reducing property of the oxoacids of phosphorus is directly proportional to the number of pH bonds. Okay, that means more the number of pH bonds, more will be the reducing power. So let's check one by one. First one is H4P2O7. Okay, so here two phosphorus are joined by one oxygen first. Okay, then both the phosphorus have one double bond oxygen and the rest will be OH bonds. Okay, so OH, OH, OH and one more OH. So is there any phosphorus hydrogen bond here? No. So no phosphorus hydrogen bond is there. So first let's draw the structures of other options also, then we'll compare. In the next one we have H3PO3. This is what? H4P2O7. Next is H3PO3. So one phosphorus is there, one double bond oxygen will be there, two OH and one hydrogen. So this is H3PO3, and as we can see it has one phosphorus hydrogen bond. Okay, so one phosphorus hydrogen bond. So in the first one no phosphorus hydrogen, here one phosphorus hydrogen. In the third one we have H3PO2. So phosphorus, one double bond O will be there, one OH and two hydrogens will be there. Okay, so as we can see it has two phosphorus hydrogen bonds. Okay, so H3PO2 has two phosphorus hydrogen bonds. Now the last one is H3PO4. So let's draw the structure here. This is P double bond O and all the three OH bonds will be there. Okay, this is H3PO4. As we can see, no pH bond again. Okay, so if we have to compare the reducing property, it will be maximum for the third one because it has two phosphorus hydrogen bonds. Then the second one, that is one phosphorus hydrogen bond. The rest have no phosphorus hydrogen bonds. So obviously the correct answer will be option number C. It has two phosphorus hydrogen bonds. Okay. Now question number 65 is also from the P block elements, and the question is, identify the correct formula of oleum from the following. Okay, so here the correct formula for the oleum will be H2S2O7, that means the first one. Okay, so option number A will be the correct answer. It is also known as pyrosulfuric acid. Okay, pyrosulfuric acid. Okay, now what is the next one? H2SO3. This is sulfurous acid. Sulfurous acid. Next one is H2SO4, that is sulfuric acid. Okay, this is very common. And the last one is H2S2O8. So this is peroxy disulfuric acid. That means by combining two sulfuric acid, we get peroxy disulfuric acid. That means H2S2O8. Okay, so this is simply memory based question. You have to remember the formula. Question number 66 is related to redox reaction, and the question is, when neutral or faintly alkaline potassium permanganate is treated with potassium iodide, iodide ion is converted into X, then X is, okay. So we know that potassium permanganate, that is KMnO4, is a strong oxidizing agent. Okay, strong oxidizing agent. What is the oxidation state of manganese? +7. Okay, and it is a strong oxidizing agent. That means it will oxidize others and get itself reduced. Okay, So here this is reacting with potassium iodide. That means manganate ion MnO4 minus ion is in aqueous medium and it is reacting with iodide ion. Okay. So what will happen? It will reduce itself into MnO2 and it will oxidize the iodide into iodate, that means IO3 minus, and OH minus ion will also be formed. So on balancing we'll have 2 this side, 2 here and 2 here. Okay, so this is a balanced reaction. That means what is formed? Iodate ion, IO3 minus ion is formed. So option C will be the correct answer. Question number 67 is from the chapter Coordination Compound, and the question is the crystal field stabilization energy, that is CFSE, for cobalt hexafluoride is 18,000 per centimeter. The CFSE for cobalt tetrafluoride will be, okay, so we know that cobalt hexafluoride is an octahedral complex, right? Whereas cobalt tetrafluoride is a tetrahedral complex. So the CFSE for octahedral is given, that means delta octahedral is given, and we have to find out the CFSE for tetrahedral one, that means delta tetrahedral has to be determined. So for that we need to know the relation between these two, and the relation is delta of tetrahedral complex is equal to 4 by 9 times delta of octahedral complex. Okay. So 4 by 9 into what is delta of octahedral given in question? It is 18,000 per centimeter. So 9 into 2 is 18. So here we have 2000 and 4 into 2000 will be 8000. Unit will be per centimeter. So the answer will be 8000 per centimeter. That means option D will be the correct answer. Question number 68 is from the chapter Electrochemistry. Here some limiting molar conductivities are given and we have to find the limiting molar conductivity for acetic acid. So the first one is the limiting molar conductivity of sulfuric acid. Now if we have to write the relevant chemical reaction, it will be the dissociation of sulfuric acid. So sulfuric acid on dissociation will give 2 hydrogen ions plus 1 sulfate ion. Now let's assume this is equation number 1. In the second one we have potassium sulfate. So the chemical reaction for the dissociation of potassium sulfate will be 2K plus sulfate, right? And this will be equation number 2. Similarly, in the third one we have to dissociate potassium acetate. So let's write down CH3 COOK on dissociation will give what ions? Acetate ion, CH3COO minus plus potassium ion, and this will be our equation number 3. Now we have to find the limiting molar conductivity for acetic acid. So similarly we'll write the chemical reaction for the dissociation of acetic acid as well. So CH3COOH on dissociation will give acetate ion plus hydrogen ion, right? Now we know that according to the Colroche law, the molar conductivity of an electrolyte is equal to the sum of conductance of individual ions. Okay, and we have to find out the conductivity of acetic acid. That means we can find out the sum of the conductance of acetate and hydrogen ion to obtain the molar conductivity of acetic acid, right? So how to determine the molar conductance of acetate and hydrogen? By using the above 3 equations, because the values are given here. Okay. So where do we find the acetate ion in the above 3 equations? In the third one. In the last equation we can see the product is acetate ion and potassium ion. That means we have to use this equation once. So in equation 3 we have acetate ion CH3COO minus plus K plus. Although we don't need K plus, but we have to take it because we are using the complete equation. Okay, we cannot take half of the equation. So this is equation number 3. Now we also need H plus ion. So where do we find H plus ion? In which of the given equations? The first one. Okay. In the first one we are getting H plus and sulfate. So we have to add this equation. That means 2H plus plus SO4 2 minus. So the first one was equation 3. This is equation number 1. But we need only one H plus, not 2H plus. That means we have to divide it by 2, right? So the complete equation has to be divided by 2. So sulfate will also be divided by 2. That means equation 1 has to be divided by 2. Got it? So equation 3 plus equation 1 by 2. Now you can see that our requirement is only acetate ion and hydrogen ion, not potassium and sulfate. That means these two are useless, so these two have to be removed from here. And these two can be seen in equation number 2, right? Here you can see we have 2K plus sulfate. So if we subtract equation 2 from this, we'll remove the potassium and sulfate from here, right? So minus 2K plus sulfate. Again, we don't have to subtract 2K plus. We have to subtract only 1K plus. So we can do this by dividing it by 2. So sulfate will also be divided by 2. Now, this is equation number 2. So minus equation 2 divided by 2. Got it? Now, let's put the values. Equation 3. What is the molar conductivity given in equation number 3? It is Z. Okay. So Z plus equation 1 we have x, so x divided by 2 because this equation is to be divided by 2 minus equation 2 by 2. So what is the conductivity given in equation 2? It is y, so y divided by 2. So z plus, if we take half common, here we'll get x minus y. So this is the required molar conductivity of acetic acid. So this can be seen in option number D. Okay, so option D will be the correct answer. Now question number 69 is from the chapter Chemical Kinetics, and the question is, a first order reaction has a rate constant of 2.303 into 10 to the power minus 3 per second. The time required for 40 grams of this reactant to reduce to 10 gram will be given that log 2 is 0.3010. Okay, so we know that for a first order reaction, T half, that means half life is given as ln2 divided by k. Okay, ln2 will be equal to 0.693 and k is the rate constant, so that is given as 2.303 into 10 to the power minus 3. 2.303 into 10 to the power minus 3. So on solving this, we'll get 301 second. So this is the half life. Okay. Now we have to find out the time required for 40 gram of this reactant to reduce to 10 grams. So suppose we have 40 grams. So what amount will be left after one half life? Half of 40, that means 20 grams. Okay. Then again after one half life, half of 20 will be left. That means 10 grams will be left. Okay. So one half life here and one half life will be here. Okay, so that means from 40 to 10 grams we need two half lives. Okay, so time required will be equal to 2 times the half life. That means 2 into 301 second. So on multiplying this, we'll get 602 seconds. So the correct option will be option number D. Okay. Now question number 70 is again from the chapter Chemical Kinetics, and the question is, for a reaction activation energy equals to 0 and the rate constant at 200 Kelvin is 1.6 into 10 to the power 6 per second, then the rate constant at 400 Kelvin will be. The value of gas constant is given as 8.314 joule per Kelvin per mole. Okay, so we have two temperatures. First one is 200 Kelvin, so this is T1, and the second is 400 Kelvin, this is T2. Okay, now the rate constant at T1 is given as 1.6 into 10 to the power 6 per second. So this is K1. And we have to find out the rate constant at T2. That means we have to find out the value of K2. So let's use the Arrhenius equation here. We know that according to the Arrhenius equation, K is equal to A into e to the power minus EA by RT. Okay, you have to remember this formula. So if we put log on both sides, we'll get log K equals to log A minus EA by 2.303 RT. Okay. Log A will remain constant and we have to use K1, K2 and T1, T2. So we can write log K2 divided by K1 will be equal to EA by 2.303 R 1 by T1 minus 1 by T2. Okay. Now it is given in the question that the activation energy is 0. So this EA is 0. That means this whole expression on the right hand side will become 0. Okay. Anything multiplied by 0 will be 0. So this log K2 by K1 will become 0. Okay. So let's write it down here. Log K2 by K1 will become 0. So what will be the value of K2 by K1? It will be anti-log of 0. Anti-log of 0. And anti-log of 0 is always 1. Okay. So K2 by K1 is equal to 1. So we can say that K2 is equal to K1. Okay. So this is the relation between K2 and K1. So here we have K1 equals to 1.6 into 10 to the power 6 per second. That means K2 will also be 1.6 into 10 to the power 6 per second. That means option B will be the correct answer. Question number 71 is from the chapter Surface Chemistry. And the question is the correct option representing a Freundlich adsorption isotherm is. Okay. So what is Freundlich adsorption isotherm? It represents the relation between the extent of adsorption and the pressure. So suppose this is the surface of our solid adsorbent. Solid adsorbent. That means the material on which the gas will be adsorbed. And these are the gas molecules. Now for X mass of gas molecules adsorbed on M mass of solid adsorbent, the extent of adsorption can be represented as X by M. Okay. So extent of adsorption will be equal to X by M, right? Now if we draw a graph for this, so this will be your extent of adsorption, that means X by M, and here we have the pressure. Okay. Now the extent of adsorption will vary with pressure like this. That means with increase in pressure, the adsorption will also increase. But after a certain time, it will become constant. Okay. Because the surface will be filled completely. So no more gas could be absorbed. Now here the related equation will be X by M equals to K P to the power 1 by N. K is a constant, P is the pressure. And what is 1 by N? 1 by N will lie, it lies between 0 and 1. That means it cannot be less than 0. Okay. Cannot be less than 0. Also it cannot be more than 1. Now let's have a look at the given options. In the first one, we have Kp to the power 0.3. So does it lie between 0 and 1? Yes. So this is possible. In the second one, we have 2.5. That means it is more than 1. Okay, it is more than 1. So this is not possible. In the third and fourth, we have negative values for 1 by n. That means these are less than 0. So these are also not possible. Okay, less than 0. So not possible. So the only possible option is option number A. Therefore, it will be the correct answer. Question number 72 is from the chapter Chemical Bonding and Molecular Structure. And the question is, which of the following is paramagnetic? Options are nitrogen, hydrogen, lithium and oxygen. Okay. So what are paramagnetic substances? These are the substances that contain unpaired electrons. Unpaired electrons, and due to this, these are weakly attracted by a magnetic field. Okay. Attracted by a magnetic field. Now let's check one by one which of the given options has unpaired electrons. Now in the first one we have nitrogen. So we know that nitrogen atom contains 7 electrons. So 2 nitrogen atom or 1 nitrogen molecule will contain 7 plus 7, that means 14 electrons, right? So let's write down the electronic configuration of nitrogen. It will be sigma 1s2, then sigma star 1s2. Star means anti-bonding molecular orbital, right? Then sigma 2s2, then sigma star 2s2. Then we have pi 2px2, then pi 2py2, okay, and then we have sigma 2pz2. So 2 plus 2 4, then 6 8 10 12 and 14 electrons completed. So we can see that we have these molecular orbitals and each molecular orbital has 2 electron in it, okay. That means all the electrons are paired. See, this is one molecular orbital and 2 electrons in the same molecular orbital means both will be paired. So we can see that there is no unpaired electrons in nitrogen. So let's write it down here. Nitrogen has no unpaired electrons. That means it will not be paramagnetic in nature. In fact, it will be diamagnetic in nature. Diamagnetic means this will be weakly repelled by the magnetic field. Okay. Now, the second one is hydrogen. So this is the simplest one. We know that hydrogen atom has 1 electron. So hydrogen molecule will have 1 plus 1. That means 2 electrons. Okay. So what will be the electronic configuration? It will be sigma 1s2 only. Completed. Okay, so only one molecular orbital is there, sigma 1s, and there are 2 electrons in it. So it will be paired only. Okay, again, no unpaired electrons here. So this will also not be the paramagnetic substance. Now, the third one is lithium. So lithium atom has 3 electrons. So lithium molecules will have 3 plus 3, that means 6 electrons. Now let's write down the electronic configuration of lithium. So sigma 1s2, then sigma star 1s2, then sigma 2s2. So 6 electrons completed, 2 plus 2 plus 2. So here also we can see that all the 3 molecular orbitals have 2 electrons each. That means again no unpaired electrons. Unpaired electrons. Now the last one is oxygen. So oxygen atom has 8 electrons. So oxygen molecule will have 8 plus 8. That means 16 electrons, right? Now let's write down the electronic configuration of oxygen. So sigma 1s2, sigma star 1s2, then sigma 2s2, then sigma star 2s2, then we have sigma 2pz2, pi 2px2, pi 2py2, then we have pi star 2px1, pi star 2py1. Okay. So here we can see in the last part that we have one electron only in one orbital. That means these are sigma star 2px. This is pi star and pi star 2py, and both orbitals have one electron only. That means these are unpaired electrons. Okay. So oxygen has unpaired electrons. O2 has 2 unpaired electrons. Okay. That means it will be paramagnetic in nature. Therefore, option D will be the correct answer. Now, question number 73 is also from the chapter Chemical Bonding and Molecular Structure. And the question is, which of the following is the correct order of dipole moment? Okay. So, let's draw the structures first. First, I am drawing the structure of BF3. Because here the dipole moment will come out to be 0. See, boron is the central atom. We have 3 fluorine atoms. So 1 fluorine atom on one side and 2 fluorine atoms on the other side. So this will be the structure. And since fluorine is more electronegative than boron, so the direction will be from boron to fluorine. Okay, for electron density. Now, here we can see that on the right side we have 2 fluorine atoms. So the resultant dipole moment of these two will be in between like this. Okay. and this will be cancelled by the dipole moment on the left side. So the net dipole moment will come out to be 0. Okay, that means this BF3 should have least dipole moment. So in option number B and C, we can see that BF3 have least dipole moment. So only B or C can be the correct answer. So A and D is not correct. Now let's see whether NF3 has more dipole moment or NH3, because in both these options water has maximum dipole moment. Okay, so let's check for NF3 first. So this is nitrogen, this is fluorine, fluorine and fluorine. Okay, similarly for NH3 we'll have the similar structure: hydrogen, hydrogen, hydrogen. But what is the difference here? We know that fluorine is more electronegative than nitrogen. So direction will be like this: nitrogen to fluorine. Okay. Whereas in case of NH3, nitrogen is more electronegative than the hydrogens. Okay. So the direction will be like this. Okay. And since nitrogen has one lone pair in both these cases, so one dipole moment will go in this direction. Okay. Now in the nitrogen trifluoride, you can see that one type of dipole moment is in the downward direction and the other type of dipole moment is in the upward direction. Okay, so one will try to cancel the effect of another. Okay, that means this will be lessen, the impact will be lessen. Okay, now in the last one, that means NH3, both types of dipole moments are in the same direction. Okay, in the lower part also it is in the upward direction, in the upper part also it is in upward direction. So no one will try to cancel the other. In fact, one will try to enhance the effect of other. Okay, so this will enhanced, the dipole moment will be enhanced. Okay, that means which should have more dipole moment? NH3. Okay, NH3 should have more dipole moment. So BF3, then NF3, then more than NF3 will be the NH3. Okay, and then maximum is water. Let's draw the structure of water also. This is oxygen, this is hydrogen, this is hydrogen, and oxygen has how many lone pair of electrons? Two lone pairs of electrons. Okay, so we have one dipole moment like this and the other dipole moments like this. Okay, so this has maximum dipole moment. That means the correct order should be the second one, BF3, then NF3, then NH3, then water. So option B will be the correct answer. Question number 74 is from the S block elements, and the question is: crude sodium chloride obtained by crystallization of brine solution does not contain. Options are magnesium sulfate, sodium sulfate, magnesium chloride and calcium sulfate. So the correct option will be option number A, that is magnesium sulfate, because this is not found in that crude sodium chloride that is obtained by crystallization of brine solution, whereas other three are found. So if we list all the compounds that are found, these are sodium sulfate, then calcium sulfate. So these are the sulfates, and then there are some chlorides such as calcium chloride and magnesium chloride. Okay. So we can see that magnesium sulfate is not there, therefore this will be the correct answer. Question number 75 is also from S block elements, and the question is: which of the alkali metal chloride forms its dihydrate salt easily? Okay, options are lithium chloride, cesium chloride, rubidium chloride and potassium chloride, and the correct answer will be option number A, that is lithium chloride. And what is the reason? Reason is the hydration tendency of lithium ion. So out of the given options, lithium ion has maximum hydration tendency. Okay, maximum hydration tendency, therefore it forms dihydrate salt, dihydrated salt, that is lithium chloride 2 H2O. Okay. Question number 76 is from the chapter Equilibrium, and the question is: the pH of 0.01 molar aqueous NaOH solution will be. Okay, so the concentration of OH minus is given, it is 0.01 molar. So we can write it as 10 to the power minus 2. Okay. Now we can find out the value of POH, because POH is equal to minus log of OH minus concentration. Okay. That means minus log 10 to the power minus 2. So here we'll get minus 2, that means plus 2. Okay. So this is the value of POH. Now we have to find out the pH, and we know that pH plus POH is equal to 14. So pH will be equal to 14 minus POH, right? 14 minus POH is 2. So 14 minus 2, that will be 12. So the correct option will be option number C. Question number 77 is again from the chapter Equilibrium, and the question is, which of the following cannot act both as Bronsted acid and Bronsted base? Okay, so what are Bronsted acid? These are the species that can donate a proton. Okay, donate a proton, that means H plus ion, whereas Bronsted base can accept a proton. Accept a proton. Now, let's check one by one. First one is hydrogen carbonate, HCO3 minus. Now, it can either donate or accept a proton. So, suppose it is donating a proton, that means one H plus is removed. Then what will be left? CO3 and 2 minus. Okay, one negative charge will be there. And on the other hand, it can also accept a proton. So, plus H plus, that means one more hydrogen will be added. So, it will form H2CO3. Okay, that means this is acting as a Bronsted acid as well as Bronsted base. Okay, now we talk about second one. This is ammonia, NH3. Now this can also accept or donate a proton. So suppose it is donating a proton, then one hydrogen will be removed. So what will be left here? NH2 will be left. Okay, NH2 minus. Now if it accepts a proton, it will form NH4 plus. Okay, now come to the third one. So we can see that ammonia is also acting as a Bronsted acid and Bronsted base. Now the next one is HCl. So here it can donate a proton. So it will form chloride ion. Okay, but it cannot accept a proton. Okay, so we can see that this is acting as a Bronsted acid, not a Bronsted base. Okay, Bronsted acid, but not as Bronsted base. So this will be the correct answer here. Okay, if we talk about the last one, that means hydrogen sulfate, HSO4 minus, then this can also donate or accept a proton. So when it is donating a proton, it will form SO4 2 minus, and when it is accepting a proton, it will form H2SO4. Okay, so we can see that only HCl is the one which is not acting as Bronsted acid as well as Bronsted base. Others are acting as both. Okay, so option C will be the correct answer. Question number 78 is also from the chapter Equilibrium, and the question is, the molar solubility of calcium fluoride in 0.1 molar solution of sodium fluoride will be. Okay, so we have two electrolytes here. First one is calcium fluoride and the other is sodium fluoride. So let's write down the reaction for the dissociation of each one of them. First one is calcium fluoride. Now when it gets dissociated, it will give us calcium ion and 2 moles of fluoride ions, right? Similarly, when sodium fluoride is dissociated, it will give us sodium ion plus fluoride ions, right? Now here suppose that the solubility of calcium fluoride is A, and after dissociation it will be A minus S, because the solubility of calcium will be S, and what will be the solubility of fluoride? It will be 2S, because we have 2 moles of fluoride ions, right? And in case of sodium fluoride, it is given that the concentration of sodium fluoride is 0.1 molar, right? So 0.1 molar, and initial concentration of sodium and fluoride will be 0, but after dissociation it will be 0.1 molar each. Okay. So here we need to remember one thing, that calcium fluoride is a weak electrolyte, whereas sodium fluoride is a strong electrolyte. Now why I am mentioning this? It is because we know that when a weak electrolyte is mixed with a strong electrolyte and there is a common ion in both of them. So here we can see that fluoride is common in both, right? So whenever there is a common ion between weak electrolyte and strong electrolyte, then what happens? Due to common ion effect, the solubility of the weak electrolyte decreases. Okay, it decreases such that it is negligible as compared to the solubility of the same ion in the strong electrolyte. Okay, that means this solubility S will be much less as compared to the solubility in case of strong electrolyte, that means 0.1. Okay, so we can see that whenever these two will be mixed, what will be the total concentration of fluoride ion? Total fluoride ion will be 2s plus 0.1, right? But due to common ion effect, this S will be much less as compared to 0.1. Okay, so due to common ion effect, S will be much less than 0.1. Therefore, we can write that the total concentration of fluoride will be about 0.1 only, because 2s will be negligible. Okay. Now what is given in the question? Ksp of calcium fluoride is given. Okay. So we know that Ksp is equal to the product of concentrations. So it will be concentration of calcium ion into concentration of fluoride ion. Okay, and it will be square because 2 moles of fluoride ions are there. So Ksp is 5.3 into 10 to the power minus 11 equals to the solubility of calcium ion is S and the solubility of fluoride is 0.1. Okay, so 0.1 square. So here we can write that S will be equal to 5.3 into 10 to the power minus 11 divided by 10 to the power minus 2. Okay, so in solving this, we'll get 5.3 into 10 to the power minus 9. Okay, so the correct option will be option number C, 5.3 into 10 to the power minus 9 mole per liter. Okay. Now question number 79 is related to redox reaction as well as DNF block elements, and the question is the oxidation state of chromium in CrO6 is. Okay, so if we use the common method to find out the oxidation state, then we'll say that the oxidation state of chromium is X, and we know that the oxidation state of each oxygen is -2, so it will be -2 into 6 here, and the sum will be equal to 0. Okay, so x minus 12 will be 0 and x will come out to be plus 12, but this will be incorrect. Why? Because we know that the oxidation state of chromium cannot be more than 6. Okay, so oxidation state of chromium cannot be more than plus 6. Therefore, this method is not valid here. Okay, so we'll use some other method. So for that, let's draw the structure of CrO6. This is chromium. Now we have 3 oxygens here. So 6 oxygens in total. So 3 on the one side and 3 on the other side. Okay. So let's connect them. Now here we can see that the oxidation state of each oxygen atom will be -1. Okay, so we have 6 oxygen atoms, so it will be -1 into 6 plus the oxidation state of chromium, that is X, will be 0. So -6 plus X will be 0. That means the oxidation of the state of chromium will be equal to +6. Okay, therefore the correct option will be option number C. Question number 80 is from the chapter Coordination Compounds, and the question is the number of hydrogen bonded water molecules associated with copper sulfate pentahydrate is. Okay, so we have to find the number of water molecules that are making hydrogen bond. So this is the coordination compound. Let's draw the structure first. This is copper and 4 water molecules will be directly linked with this copper. Okay, so this is oxygen, hydrogen, hydrogen. So this is one water molecule. Then one more water molecule this side, oxygen, hydrogen, hydrogen. Then again one water molecule this side and one more water molecule this side. Okay, so four water molecules are there that are linked directly with the copper, and this part will be inside the coordination sphere. Okay, but in this coordination compound we have five water molecules, so one water molecule will be outside the coordination sphere. So this is oxygen, hydrogen, hydrogen, and it will be linked by making hydrogen bond with other water molecules. Okay, and the anion is sulfate, so let's draw sulfate as well. S double bond O, double bond O, and then two single bond with oxygen. So as we can see that this one water molecule is making hydrogen bond, therefore the number of hydrogen bonded water molecule will be only one, therefore option B will be the correct answer. Now question number 81 can be related to solid state as well as D and F block elements, and the question is formula of nickel oxide with metal deficiency defect in its crystal is nickel 0.98 oxide. The crystal contains nickel 2 plus and nickel 3 plus ions. The fraction of nickel existing as nickel 2 plus ions in the crystal is. Okay, so we have nickel oxide, and in this the nickel consists of two types of ions, nickel 2 plus ion as well as nickel 3 plus ions. Okay, now if we assume that the nickel 2 plus ion is present in X amount, then what will be the amount of nickel 3 plus ion? It will be 0.98 minus X, because the total nickel is 0.98. Okay, now what will be the charge on each of these ions? The charge on nickel 2 plus will be 2 into X, that is 2X, and the charge on nickel 3 plus will be 3 into 0.98 minus X. So if we open the bracket, we'll get 3 into 0.98, that means 2.94 minus 3x. Okay, so this is the charge on total nickel 3 plus ions. Now what will be the charge on oxygen? It will be minus 2. So we can use the law of conservation of charge here. So by the law of conservation of charge, the sum of all the charges in this compound will be 0. Okay, that means the charge on nickel 2 plus charge on nickel 3 plus the charge on oxygen will be equal to 0. Okay, what is the charge on nickel 2 plus? It is 2x. The total charge on nickel 3 plus is 2.94 minus 3x, and the charge on oxygen is minus 2, and the sum will be 0. Okay, so here we get 2x minus 3x, that means minus x. 2.94 minus 2 will be 0.94, right? Will be equal to 0. So we can say that x is equal to 0.94, and we have assumed that x is the amount of nickel 2 plus ions in the total nickel. Okay, so what will be the fraction of nickel 2 plus? Fraction of nickel 2 plus will be the amount of nickel 2 plus present in the total amount of nickel, that is 0.98. Okay, so x is equal to 0.94 and the total nickel is 0.98. So fraction will be 94 divided by 98. Now if we divide it, we'll get 0.959. Okay, so that will be equal to 0.96. Okay, so the correct option will be option number A, 0.96. Question number 82 is from the chapter solutions, and the question is which of the following statements is correct regarding a solution of two compounds A and B exhibiting positive deviation from ideal behavior. Okay, so what is positive deviation? It means the vapor pressure of the solution will be more than expected. More than expected. And when will that happen? Let's see. Suppose we have a solution having two types of compounds, compound A and compound B. Okay, so what will be the types of interactions here? There will be two types of interactions. First type of interaction will be among the molecules of same compound, that means AA and BB. And the other type of interaction will be between the molecules of different compounds, that means between A and B. So what will happen in case of positive deviation? The vapor pressure has to be more. That means the compound should be able to escape from it. Okay, any one of the compound, either A or B, should be able to escape the solution in the form of vapor. And this can only happen when the interaction between A and B is weaker. Okay, or we can say that the interaction between A and B individually should be stronger as compared to the interaction between A and B. So this will lead to increase in vapor pressure, thus making it positively deviated. Okay, so the first option is intermolecular attractive forces between A and B are stronger than those between A and B. So this is a correct statement. So in the first option only we have found the correct answer. Now on the other hand, what will happen when this interaction will be stronger? When the interaction between A and B is strong, then none of them will be able to escape. Okay, so there will be no vapor pressure here, so it will lead to negative deviation. Negative deviation means stronger interaction between A and B. Okay, so first option is correct according to this question. The second option is enthalpy of mixing is 0 at constant temperature and pressure. This is wrong, because for positive deviation it will be positive. Okay, enthalpy of mixing will be more than 0, and the volume of mixing will also be positive. Okay, and on the other hand, in case of negative deviation, will be negative. So I hope you understood this. Now let's come to question number 83. It is from the chapter States of Matter, and the question is, in water saturated air, the mole fraction of water vapor is 0.02. If the total pressure of the saturated air is 1.2 atmosphere, then the partial pressure of dry air is. Okay, so we have air that is saturated with water. That means we have a mixture of dry air and water vapor. Okay, and in this the mole fraction of water vapor is 0.02. So what will be the mole fraction of dry air? It will be 1 minus 0.02, that is 0.98. Okay, now we have to find out the partial pressure of dry air, and we know that partial pressure is equal to the product of total pressure and the mole fraction, right? So partial pressure of dry air will be equal to the total pressure of the mixture into the mole fraction of dry air. Okay, total pressure is given as 1.2 atmosphere and the mole fraction of dry air is 0.98. So on multiplying this, we'll get 1.176 atmosphere. So this will be the partial pressure of dry air. That means option number C will be the correct answer. Question number 84 is from the chapter Electrochemistry. Here some standard electrode potential values are given, and we have to arrange them in decreasing order of reducing power of the metal. So we know that standard electrode potential is also known as standard reduction potential, and the reducing power of a metal is inversely proportional to standard reduction potential, right? So let's write it down here. Reducing power of metal is inversely proportional to the standard reduction potential. And here we have to arrange them in decreasing order of reducing power. That means maximum reducing power to minimum reducing power. So it will be from minimum standard reduction potential to maximum standard reduction potential. Okay, minimum standard reduction potential to maximum standard reduction potential. So which is the minimum value for standard reduction potential? It is minus 2.93 volt here. Minus 2.93 volt. Then the next one will be minus 1.66. Then the next one will be minus 0.74 volt. And the maximum value is 0.80 volt. Now minus 2.93 is for the third one, that is potassium, right? So this is for potassium. Then minus 1.66 is the first one, that is aluminium. Then minus 0.74 is the last one, that is chromium. And 0.80 is the second one, that is silver. So this should be the correct decreasing order of reducing power of metal. That means option B will be the correct answer. Question number 85 is from the chapter solutions, and the question is the density of 2 molar aqueous solution of NaOH is 1.28 grams per centimeter cube. The molality of the solution is. So we have to find out the molality of the solution, and what is given in the question? Molarity is given. Okay, it is given that we have 2 molar aqueous solution. So this is the molarity, and we know that molarity is equal to number of moles of solute, number of moles of solute divided by volume of the solution in liter, or we can say number of moles of solute per liter of the solution. So it is given as 2 molar. That means there are 2 moles of NaOH in 1 liter of the solution. There are 2 moles of NaOH in 1 liter solution. So number of moles here is 2, volume is 1 liter. Density is given as 1.28 grams per centimeter cube, and we know that 1 centimeter cube can be written as 1 milliliter. So it is equal to 1.28 grams per milliliter. So volume is known, density is known. So can we find out the mass of NaOH? It will be equal to volume into density. Volume is 1 liter, that means 1000 milliliter into density is 1.28 grams per milliliter. So milliliter cancelled. So what is the mass of NaOH? It is 1280 grams. So this is the mass of solution. Now we can write that mass of solution is 1280 grams. And what will be the mass of solute? It is equal to 2 into molecular mass, that means 2 into 40 grams per mole. Here you can see. So this is 80. So 80 grams is the mass of solute. Now we have to find out the mass of solvent because this is required in case of molality. So mass of solvent will be equal to mass of solution minus mass of solute. That means 1280 grams minus 80 grams. So it is equal to 1200 grams. So this is the mass of solvent in grams, but in case of molality, we need the mass of solvent in kg. So it will be equal to 1200 divided by 1000 kg. Okay. So 20 cancelled and it will be equal to 1.2 kg. So now we can find out the molality. Molality is equal to number of moles of solute divided by mass of solvent in kg. Number of moles of solute divided by mass of solvent in kg. So number of moles is 2. Mass of solvent in kg is 1.2 kg. So on dividing this, we'll get 1.67. Okay. And this is the answer. That means option C will be the correct answer. Question number 86 is from the chapter Structure of an Atom, and the question is orbital having 3 angular nodes and 3 total nodes is. Options are 5p, 3d, 4f and 6d. Okay. So we know that the number of angular nodes is equal to the azimuthal quantum number, that is small l. Okay. Whereas the number of radial nodes is equal to n minus l minus 1, where n is principal quantum number and L is azimuthal quantum number. But here we can find out the correct answer using the azimuthal quantum number only. Okay, this is equal to angular nodes, and it is given that we have 3 angular nodes. Okay, that means the value of L should be 3, right? And we know that the value of L for s orbital is 0, for p orbital it is 1, for d orbital it is 2, and for f orbital it is 3. That means we should have f orbital, right? So we have only one option where we have f orbital. That means option C will be the correct answer. Now let's try to confirm this answer by finding the principal quantum number. Okay, so it is given that radial nodes is equal to n minus L minus 1. So what will be the total number of nodes? It will be the sum of angular and radial nodes, right? Angular plus radial. It is given that we have 3 total nodes. Okay, so 3 equals to angular is L, radial is n minus L minus 1. So L cancelled. What is left here? N minus 1. Okay, so n minus 1 is equal to 3. That means 3 plus 1 will be equal to the n, or the principal quantum number. So it is clear that n should be 4. Okay, so now we know that n should be 4, L should be 3. So it will be 4f. Okay, so option C will be the correct answer. Now question number 87 is from the chapter Structure of an Atom, and the question is, in hydrogen atom, the de Broglie wavelength of an electron in the second Bohr orbit is. So we have to consider the second Bohr orbit, that means n equals to 2. So we know that according to the Bohr's theory, angular momentum, that means mvr is equal to nh by 2 pi, and n is equal to 2 here, so that will be equal to 2h by 2 pi. 2 will be cancelled, so only h by pi will be left. That means mvr is equal to h by pi. So what will be the value of h? It will be equal to mvr into pi. Now let's assume this is equation number 1. Now let's come to the de Broglie wavelength that is asked in the question. So we know that de Broglie wavelength, that is lambda, is equal to h by p. P is the momentum here. So h by mv, because momentum is mass into velocity. So according to this equation, the value of h will be equal to mv into lambda, right? So let's assume this is equation number 2. Now both give us the value of h. That means we can equate these two equations. So mvr pi will be equal to mv into lambda. Now mv cancelled. So lambda is equal to r into pi, and this is the lambda that we have to calculate. So what is r? R is the radius, and r will be equal to 52.9 n square by z picometer. N is the number of orbit that we are talking about. So here it is second orbit, that means it will be 52.9 into 2 square divided by atomic number. So atomic number of hydrogen is 1. So 52.9 into 4 will be, on calculating it, will get 211.6. Okay, so here we'll get 211.6 pi picometer. So which option should be the correct one? Option number B will be the correct answer. Question number 88 is from the chapter States of Matter, and the question is, the volume occupied by 1.8 grams of water vapor at 374 degrees Celsius and 1 bar pressure will be. The value of gas constant is given here. Okay, so we can simply use the ideal gas equation, that is PV equals to nRT. Now what values are already given in the question? Pressure is given, it is equal to 1 bar. Then the value of gas constant is already given. Okay, it is 0.083 bar liter per Kelvin per mole, right? Then what else is given? Temperature is also given. It is 374 degrees Celsius. So in Kelvin it will be 374 plus 273 Kelvin. That means 647 Kelvin. Okay. Now, mass is given. Number of moles is not given, but mass is given, and with the help of mass, we can find out the number of moles. Okay. So we know that number of moles is equal to given mass, that is small m, divided by molar mass of water, capital M. Okay. So given mass is 1.8 grams and the molar mass of water is 18. How? Because we have H2O, that means 2 into 1 plus oxygen is 16. So it will be 18. Okay. So on solving this, we get 0.1. So we have 0.1 moles. Now we can find out the volume, that is equal to nRT divided by P. Number of moles we have already calculated, it is 0.1. The value of R is already given in the question, it is 0.083. And temperature is also given, it is 647 Kelvin divided by P. So P is 1 bar. Now on solving this, we'll get 5.37 liter. Okay. So the correct option will be option number D. Question number 89 is from the chapter Thermodynamics, and the question is, an ideal gas expands isothermally from 10 to the power minus 3 meter cube to 10 to the power minus 2 meter cube at 300 Kelvin against a constant pressure of 10 to the power 5 Newton per meter square. Now the work done on the gas is, okay, so the initial volume is given, final volume is given. The process is isothermal, so the temperature will remain constant, that is 300 Kelvin. Okay. And the pressure is also constant, and that is equal to 10 to the power 5 Newton per meter square. Now we have to find out the work done. So we know that the work done in case of isothermal process is equal to minus P external into delta V. Delta V is the change in volume. So we can write minus P external V final minus V initial. Okay. What is the external pressure? 10 to the power 5. So minus 10 to the power 5. Final volume is 10 to the power minus 2. Initial volume is 10 to the power minus 3. Okay. Now how to solve it? First we'll write minus 10 to the power 5. Then we can take 10 to the power minus 3 outside the bracket. So what will be left inside the bracket? 10 this side, because if we multiply 10 to the power minus 3 by 10, we'll get 10 to the power minus 2. Okay. Minus this side only 1 will be left because 10 to the power minus 3 has been taken out. Now 10 minus 1 will be 9. Minus sign is also there. Minus 9 into 10 to the power 5 is there and 10 to the power minus 3 is there. Okay. That means 10 to the power 5 minus 3. So here we'll get 9 minus 9 into 10 to the power 2 or minus 9 into 100. So on solving this, we'll get minus 900 and the unit of work is joule. So the correct answer will be minus 900 joule. That means option B will be the correct answer. And now the last question is from the chapter Thermodynamics, and the question is, reversible expansion of an ideal gas under isothermal and adiabatic conditions are as shown in the figure. So here AB represents the isothermal expansion, that means this upper graph, and AC, that means this lower graph, represents the adiabatic expansion. So which of the following options is not correct? Now we have to find out the incorrect option. First option is that entropy change in case of isothermal is more than entropy change in case of adiabatic. So we know that the entropy change is equal to Q by T, where Q is the heat transfer, and T is the absolute temperature, right? And in case of adiabatic process, there is no transfer of heat, that means Q is equal to 0. Therefore, we can say that entropy change will also be 0. But in case of isothermal, heat transfer will take place. That means the value of entropy change will be more here. So the first option will be correct one. But we have to find out the incorrect. Okay. So let's move to the second option. It says that TA is equal to TB. So we are talking about the upper graph AB, and this is for isothermal, and in case of isothermal, temperature remains constant, right? In isothermal process, temperature is constant. That means temperature at all the points in this graph will be same. So here initial temperature and final temperature will also be same. So this is also a correct one. So let's move to the third option. It says that work done in case of isothermal is more than work done in case of adiabatic. Now we know that the PV graph, the area under the PV graph gives us the work done. Okay. So let's check which one has greater area. This is the lower graph, that is for adiabatic, and this is the area A1. Okay. Whereas in case of isothermal, that means the upper graph has a much greater area, right? This is A1, suppose this is A2. So the whole area under this isothermal graph will be A1 plus A2, shaded plus unshaded. So obviously this has more area. Therefore the work done in case of isothermal will also be more as compared to the work done in case of adiabatic. Okay. So the reason is that area under PV curve is more in case of isothermal than the adiabatic. Okay. So obviously the first three options are correct. Then the only incorrect option can be the last one. But still let's check. It says TC is greater than TA. So here we are talking about the graph AC, that is for adiabatic expansion. Now what happens in case of adiabatic expansion? In adiabatic expansion, the temperature decreases. Okay, so the temperature drops and there is cooling effect. Therefore the final temperature will be lower than the initial temperature. That means TC should be lower than TA, not higher. Okay, therefore this is an incorrect option. Okay, so option D will be the correct choice here. So here we complete all the questions from this paper. I hope this session was helpful to you. So we'll get back with another session. Till then, keep learning, keep scoring high. For any doubt related to papers, join our Telegram channel. Link is given in description. Also, do subscribe our YouTube channel for more such informative videos. Thank you.